Okay, well, thank you, and thank you for inviting us to your technical subcommittee meeting. And before I start, can everybody hear me okay?
Yes.
Okay, great. I'm Radhica Kanniganti, and my colleague here is Charmagne Ackerman, and we are part of the air permit section at EPA Region 5. We are also on a work group that looks at innovative solutions and best practices for industry, and we try to disseminate the information to our state counterparts. Today we will be talking about advanced monitoring technologies and how these can be leveraged in a way that is most beneficial to facilities. And we hope this information is useful in offering a perspective of how facilities can view their operations. Here we're going to be talking about some tools that we think will assist facilities to look at their operations a bit differently. So if you look at a process stream in every facility, we have inputs to the process, the actual process, and the product. And there's an environmental impact associated to each of these. How we address this impact will really depend a lot on how well we understand the source and the cause of impact. That is really the sense of our presentation today. So how do you better monitor your process and understand it? And more importantly, what tools are available today to monitor your processes more effectively and with more precision? And how can monitoring the process help address issues proactively? How does this help facilities be more responsive in case of incidents? For example, if you look at the inputs to a facility, it could be chemicals in the case of, say, ethylene oxide sterilizers, coal piles in the case of coal handling facilities, sand and asphalt. So the process, for example, could consist of combustion sources, tanks, pipelines, and the source of emissions could be at any point in the facility. Smart and effective monitoring will help identify these problem areas so they can be addressed efficiently. For example, a company can decide to employ pollution prevention strategies, maybe change the chemical that they're using, or could look at influencing the frequency of maintenance, or decide on what control equipment they have. So really the key here is to understand the process, and that's what we will be looking at in how to use some of these advanced monitoring technologies.
Okay, so some examples of advanced monitoring technologies that we will be looking at today are effective fugitive dust control plans, optical imaging, thermal imaging, infrared cameras. So what I mean by effective fugitive dust control plans, essentially it means clearly spelling out what to do and, more importantly, when to do it, just so there's no ambiguity for the facility on how they can mitigate some issues as they arise. A lot of these plans specify what needs to be done, but may not have the information of when these actions need to be taken. And how does the facility know when to take each action? This is where the monitoring comes in. With regard to optical imaging, it's basically like a surveillance camera, where in a surveillance camera you're looking at who is walking around your facility, but as far as the context that we're using optical imaging, you're looking at the emissions that or visible emissions from different operations at the facility. And the advantages of this system is that it's continuous and can be seen remotely, and the appropriate action can be taken immediately. Thermal imaging is utilizing a heat sensing camera. These are low-cost thermography cameras that you could likely get like at Home Depot or whatnot. And these can give a visual representation of temperature differentials. You would be able to see hot spots to see if further maintenance or repair is required. And these are useful in processes like ductwork from like a hot process where you could see if there are perforations in the duct line, or if the heat emission, or if the emissions from like a hot process are not all being captured by the ventilation system. Additionally, you could take a look at equipment to see if there are places where there are increased friction. It will usually be depicted by a temperature differential, and that might mean that the increased friction would ultimately lead to failure within that system. So just as a precautionary looking, proactive look towards maintenance. And then the last item I have on there is for infrared cameras, and this is the use of IR technology to detect VOC emissions. And this is useful in pipelines, and also tanks, and chemical processes, and those sorts of industries. So what are the benefits to this process, or to your process in looking at with proactive monitoring? By proactively monitoring your process, it will give you a baseline and allow you to see the fluctuations or changes which can indicate that maintenance or attention is needed. And this can translate to increased efficiency of the process, increased worker safety, a reduction in downtime, and being a conscious member of the community. For those folks familiar with lean or improving efficiency, the first step is to know your process so you can identify where changes can be made. So I have a little story. My sister was an intern for a cell phone manufacturer. She was a pollution prevention intern quite some years ago. But she did a process analysis to determine where either they could recoup some savings or eliminate some waste. What she ended up finding, so she went through and went through each step of the process in this manufacturing process, and noticed that they were using a soldering paste, and with the excess paste, they were actually just putting it in disposal containers and taking it off site and getting rid of it. So she ended up asking, is it possible to reuse this resource, this soldering paste? And they did a little more research into it and found out that yes, they were in fact able to reclaim some of it, and ended up having a significant amount of cost savings by reusing what they were originally just paying for disposal of. So really the point of that story is to know what's happening in your process. And additionally, by identifying your baseline and whatnot, you can also, you'll be able to identify maintenance needs early, so you can reduce unexpected outages or even permit deviations, which can be very costly and time-consuming. The information that you gather from monitoring can also be used to address citizen concerns and identify the root causes for complaints that might be received, and provide a response. So additionally, consumer values are changing, and there is an increased consumer focus on social and environmental policies and responsibilities of the companies that they support. So really, knowing your process is a primary step in ensuring that your process aligns with your sustainability and environmental values. So the next couple of slides will feature some advanced monitoring technologies, and these, the next two slides are methods that have been promulgated in EPA's regs as alternative methods and can be used to fulfill regulatory requirements. This first technology is the digital opacity camera system. It is promulgated as ALT-082, which is an alternative method to reference method 9 for opacity. And the digital opacity camera system, or DOCS, works with several off-the-shelf cameras, and even the refinement of the method over the years, I think it's able to use digital photos from even smartphones with the proper settings. This method uses an analyst service which compares pixelation density between the background and the plume in the photo. And a report is generated based on the photo readings taken. The method follows the sighting requirements and timing of method 9 readings, and operators go through a one-time certification process and maintain their certification by submitting photos for analysis every 3 to 6 months. This system does utilize the service of a third-party analyst, which does have a cost, and that cost will vary based on the user needs. But a unique feature of the DOCS system is that it has the ability to analyze nighttime opacity readings, which is where method 9 you can't use method 9 for nighttime. Okay. The next technology is optical gas imaging, or OGI. And OGI would be useful for chemical manufacturing facilities or other facilities that are required to conduct leak detection and repair monitoring. It has been promulgated as an alternative work practice to reference method 21 in parts 60, 63, and 65. The general provisions in those parts outline the work practice. While OGI is unable to provide the concentration of the leak, it is still a very useful tool. Some of the benefits to this technology is being able to conduct leak detection inspections more efficiently by making the invisible visible. A company can easily see where additional monitoring attention is required. Additionally, companies can pinpoint the source of a leak and ensure they're repairing a problematic component. I was speaking with a company about their use of OGI in their process, and they told me an anecdotal story about how they were doing their LDAR monitoring and saw that actually they were doing reference method 21 and saw that there was a leak that needed, a component that was leaking and needed to be fixed. So I believe there were several components in the same general area. So they fixed the component that they thought was leaking, checked it again, method 21, still said it was leaking. I think they went through, 3 repairs before they used the OGI to find out that it was actually a component that was underneath the one that they were fixing. That was actually the one that needed repair. So finally, they were able to pinpoint the exact source of the leak and make the correct repair, and we're no longer, they didn't have any more leaks after that. Additionally, the camera can be used as an early detection tool for gap seal failures at storage tanks, or be used to identify malfunctioning tank vents. So not only will the company benefit from mitigating lost material, the environmental impact is also reduced. And recently we've seen facilities include the use of OGI as an option within their permit. So by including this option, the notification or request to the state for the use of the alternative is then streamlined. OGI is an investment. Besides the equipment the cost of the equipment, there are training requirements for the operators. However, there may be contractors and monitoring companies in your area that utilize OGI as part of their monitoring services. So taking advantage of this technology may still be within reach for even the smaller businesses.
From technologies, let's move on to work practices that can be strengthened and made more effective. This graphic shows various sources of fugitive dust within a facility. An effective fugitive dust plan should encompass all sources of fugitive dust in the facility to effectively address it. So an effective fugitive dust plan is one that addresses 4 questions: where, what, when, and who. It should have information on the process unit or activity in question that we're addressing. What are the dust mitigation or control measures and record keeping that need to be undertaken? Under what circumstances does this measure need to be implemented, and what is the frequency? And who is going to be implementing this measure? The more specific a fugitive dust plan can be, the more effective it is. So here are some examples from our people who go out for the enforcement. These are some of the real-world examples that they have seen with regards to the fugitive dust plan at facilities. So for example, the fugitive dust plan would say spraying should be done during abnormal conditions, or what are normal and versus abnormal conditions, and with no specification in the fugitive dust plan as to what these conditions are or how an abnormal condition is defined, it's very difficult to see what, to understand what the fugitive dust plan is trying to say. Another example is the fugitive dust plan could say something like, water trucks shall be utilized on an as-needed basis, or water spray should be used once a day to control dust, and it's not clear as to what process they're talking about and when. The dust may actually be generated sometime later during the day, whereas the watering would be done in the morning, and that is really not an effective use of the fugitive dust plan, and that serves no purpose. So perhaps the dust plan should be more specific, like during periods of maximum truck traffic, roads should be watered at least twice per shift or more until no visible dust is observed. So having that kind of specificity strengthens the fugitive dust plan and makes that more effective in controlling dust. So in general, really a quantitative language is preferred over qualitative. There are also many available and emerging technologies that can be used to mitigate fugitive dust from a facility. As a process-specific customized applications allow for the ability to control at the point of emissions. For example, the pictures on the right, which are obtained from the Wisconsin Permitting Authority, they show an enclosed chute to transfer material and a dustless spout to minimize the dust that's generated. And there are other technologies in the market that would allow for minimal dust generation from that source. There are also certain products that could be used to, say, control fugitive dust during freezing weather, where some of you might experience. And these are materials that are already in the market, and you may be aware of it. They are crust-forming chemicals such as mineral salts, petroleum resins, asphalt emissions, acrylics, and adhesives. There are also non-petroleum, non-toxic synthetic materials that can be used as dust suppressants. Lastly, one can also use a dry fog mist, which are basically these misters use very high water pressure to squeeze the water through really small orifices to ensure that dust is not airborne. And all these technologies can be used for freezing conditions. Wind erosion control, these are common controls, maybe commonly or not so commonly employed. Trees, bushes, barriers, or the use of an air curtain, which is typically for an enclosed source of dust. These can be used for controlling fugitive dust emissions.
So on this slide, we have some innovative monitoring solutions versus video camera surveillance. And it's really just the use of video cameras as a remote monitoring tool. This idea is similar to a baby monitor, like one of the fancy video ones, but I think that's all they have now, but with the sound off. But you have the video camera set up to visually monitor an area, and as somebody checks the video feed on a regular interval to see if actions need to be taken. This can be used as a trigger for corrective action implementation, or if the permitting authority allows it, in place of visible emission checks. And just to clarify, this cannot be done in lieu of method 22 or method 9, as EPA has not promulgated it in its rules. However, we did have a facility include in their permit the use of video cameras along with other fugitive dust control measures as part of their BACT when they did an expansion of their facility where there was a high potential for fugitive dust. The next innovative solution is thermal imaging, which I mentioned a little bit before, where the thermography cameras that have a visual depiction of temperature differentials. And like I said, it can be used to track hot process emissions along ductwork to see if there are pin leaks or emissions escaping the ductwork before it gets to a control device, or if you have hot emissions that are supposed to be going into a collection hood, you should be able to see if some of them are actually going outside and escaping the hood. And then, like I said, for internal components, you might be able to see, like in a bag house, if there are hot spots where there are ball bearings that are showing increased temperature due to friction. That might be a sign that there is some wear and tear on those parts, and that they may ultimately lead to failure. So it might prompt some maintenance earlier than expected. But again, it's a matter of being proactive and knowing the process before it becomes either a problem, and that could, just mitigate some other issues along the way. And the last thing I have down there is existing security equipment, and this kind of ties into the video surveillance idea, which many facilities do have security equipment already in place. But if it's acceptable to the permitting authority as well as useful for the facility to be able to have double duty on those security cameras, to be able to also monitor fugitive emissions that might be coming from certain points at the facility. Again, prompting reaction or the implementation of corrective action.
And one thing to add about the thermal imaging is also that it would help increase the energy efficiency in a facility by just trapping the heat within the process. Moving on to the right side of the slide, while drones today are being used to monitor the status of electric lines and pipelines, they are just making their way into the realm of environmental monitoring. So you've got drones that carry the thermal and optical imaging cameras. They can be mounted on the drones and can be used to monitor large facilities or long pipelines. Real-time data can be collected, and this is especially useful when the facility is large and has several potential leakage points. This is emerging technology that that is just being introduced into the market.
So process knowledge can be extremely beneficial to facilities. We've discussed advanced monitoring and how it can translate into increased process efficiency, improved worker safety, or a reduction in downtime. And all of these things essentially have an economic benefit component to them. Like I mentioned, non-compliance does get pretty expensive. And this is, being proactive about your process can definitely help you avoid getting into those situations. And additionally, I wanted to make mention that with the change in policy for once in, always in with regard to the MAC standards, knowing your process is an important first step to effectively limiting emissions from your facility to translate into enforceable permit limits. And if that's something that your facility or facilities that you talk to are interested in, I would definitely advise folks to work with the permitting authority, to work closely with them to work through that process and see what makes sense for that facility. So just a slide on how how we can help. Partially why we're here to talk to you folks today is what we as EPA can do. We can provide with guidance on technology that might fit for your particular industry or additional resources. Work with industry or trade associations to also discuss either technologies that fit or also how we can take advantage of these best practices and disseminate that information, creating a level playing field. And really, we want some of these ideas to be the norm rather than the exception. We think that being proactive and implementing some of these practices are really a win-win situation for everybody. And like I said, we would like to, be able to reach far and wide to provide this information so that, again, it's the norm rather than the exception.
And that's all we have. We are open to any questions.
This is LaRonda at the California Air Resources Board. I heard you say that some of the technology is new, and I'm wanting to know how are you validating that, because small businesses can't afford to invest twice, right? So how are you validating that the technologies that are coming online are really effective when applied?
Well, the two technologies that we talked about a little more in depth, being the DOCS, the Opacity camera system, and then also the IR camera, those are actually, those have been promulgated into EPA rules already, so they have been vetted. The other ones are kind of more the innovative solutions, like using video cameras and thermal imaging. Those are more so, those aren't necessarily for compliance purposes, but rather monitoring to see if additional action is needed. So like with video cameras, if you see that there is fugitive dust blowing around outside, then that should prompt somebody at the facility to take corrective action, whether it be that they do watering or compaction or whatever it is that is required in their fugitive dust plan. That should be their trigger to take additional action.
Okay, thank you. Here in California, we are experimenting, or will be, with more community-based monitoring, so external to the fence line. And do you have any thoughts about what best practices might be for businesses that are responding to concerns from the citizens about something they have picked up on a monitor that's external to the facility, but the public may believe it's being generated at the facility? Any thoughts?
That's a really general question with like a lot of specificity at the same time, because it very much depends on the monitors that the community are using and what it is that they're finding exactly. We do have here in Region 5, we do have a group that works with communities, and we actually have some certain communities identified that that we've taken, I guess, I don't want to say special interest, but
identified.
You're among friends, it's okay. Communities too. They're called disadvantaged communities here.
But we have identified communities in each state that there's a little more attention being paid in the the permits that come out of there, the complaints that come out of these facilities or out of these areas, and trying to connect those dots. So, like I said, the question was originally very general, but can have very specific implications depending on what it is that the community is seeing.
So, in the group that you have in Region 5, are they open to sharing information with other regions? I would imagine they are, but I'm just double checking. And then, if so, is there a contact person?
Let me get you. Yeah, I can get you in touch with the folks that are working in the communities group. We've had, we've had communities change over. I think one of the ones that was ending was along. There's a highway corridor in Illinois here that they were looking at a lot of the facilities along that highway. So they had enforcement out pretty frequently, and they, were really looking into community meetings and that sort of thing. I know there's also one on, like, in the city was also a disadvantaged community, a lot of industry, but a lot of residential is all mixed in. So let me get you in touch with some of those folks. It might be beneficial to talk to some of the communities that we have kind of closed.
That would be great.
Or moved on from, just so you can get a sense of what they did and how they did that.
Yeah, lessons learned would be terrific.
Yeah,
right.
For sure.
Because I think, if I remember right, one of the examples that they had cited was similar to the example that you mentioned, was where they the community picked up some pollution around the facility, and they were pretty sure that it was that facility, and there was resistance from that facility. And I think the EPA did some in-depth monitoring to compare the pollutants and the strain, and to really zone in on that particular facility as a source. So yeah, I think, so I think, yeah, maybe we could put you in touch with somebody who could help you out a little bit more with that.
Okay.
Yeah, if you can shoot me an email so I have your contact information.
What's your email?
It's
on the screen.
It's on the screen currently.
Okay.
Charmagne Ackerman.charmagne@epa.gov.
Okay, thank you. That's all my questions. Thank you for a good presentation.
Does anyone else have any questions or comments? Anyone have experience with using any of the tools that were mentioned? does anybody, and I'm going to pick on my coworker, Linnell, we don't deal much with fugitive emissions, or at least not with small businesses. And I don't know, is that something that every state writes into their permits, dealing with fugitive emissions, or anyone have a comment on that?
Barb, I would just say it's source dependent, and
Okay.
most of the fugitive emissions in Kansas are looked at more thoroughly on when we're dealing with new source review for PSD or non-attainment areas. And then the sources that are listed under that, under Part 52, that are required to calculate all of their fugitive in with their emissions. Has a little bit of a narrower scope in Kansas.
Well, I like those photos that your presentation had on the enclosed chute and dustless spout, and I didn't know if those were grains that were in your photos, but that's definitely something I've seen blowing around mostly in western Kansas.
Yeah, those certainly look like grain facilities. We have a lot of those in Wisconsin that we end up working with.
Okay.
And we do have a generic kind of particulate matter limit in our code that says fugitive dust has to be controlled. So we've got fact sheets on fugitive dust and
good
stuff like that. Yeah. Yep.
So that chute that you're seeing, Barb, is in Kansas. It's not really, I mean, it's a process. So, like if they're loading a truck, like at a cement plant, for instance, that's where I've seen those types of chutes. Like at a cement plant where they're actually making clinker, and then they grind it up in their finish mills, and then it goes into big storage, and then they'll have big semi trucks come in and unload it or load it up and take it off to other locations. But that's where I've seen a lot of those used. I've seen some used in grain elevators, flour mills in particular, as well. But to us, I mean, it's not really so much of a fugitive source. It's a process.
Oh,
so
I see.
You look
Yes.
at the emissions off of it. A lot of times in Kansas, our fugitive idea is when it's coming off, you have dust coming off of a storage pile, let's say, or from a haul road, not coming off a specific process or unit. Like a conveyor belt is not really considered fugitive,
That's interesting,
It's
because
gotta be
those are, yeah, well, unless you enclose the chute or enclose the building that's loading and unloading where that chute is, those open doors, or if it's an open conveyor, those for us, we generally look at those as fugitive sources, even if it's kind of like a process. But you can put enclosures on conveyors with all the sand facilities out here, sand mining. Yeah, there's a lot of that going on, but they can enclose them. It's expensive, but
or you have to do,
where you deal with the fugitive.
surfactant, water
Yep.
spray, that kind
Right.
of control.
Yep.
And regulatory wise, a lot of the equipment is, under an NSPS. So, but it may sound confusing. It's just, if it can't pass between, through a stack or vent. In Kansas, we do have a definition that is fugitive. It's just whether or not you have to count those fugitive emissions towards your overall facility emissions, and to what extent you're required to control them is dependent.
Yeah, that's a separate question. Yeah.
So in Indiana, one of the issues we've had periodically, maybe the spring and in the fall when it's windier, is dust complaints. So an inspector will go out and they will check visible emissions crossing the property line from 0 feet up to maybe, 10 to 20 feet itself. The other is if, based on the type or nature of the facility, whether they're subject to a specific opacity limit, either a state rule or a new source performance standard. Any other questions from anyone else? Well, if not, I would like to thank Radhica and Charmagne for agreeing to develop and give this presentation and to share their contact information. It was greatly appreciated.